So, good afternoon, everybody. I'm Gabriele De Capoa. I'm a software engineer for IBM Cloud for IBM Rome Software Lab. And today I try to show how IBM integrate the containers technology. So, how many of you are a Docker fan here in the room? 1, 2, 3. Okay. I would like to express why I'm a Docker fan, because this is some points, but the most important for me is resource isolation and utilization. Despite of the virtualization, containerization allows us to isolate a single process and a single application in a isolated file system that you want to set particularly resource limit, like 2 CPU and 4 gigabytes of RAM. So when you have 10,000 processes working in the same machine, I think it's very, very easy and very, very high to isolate, but containers allows to do this thing. Another thing is the easy to perform continuous development, integration, and deployment, because we always know the mess to use virtualization into a continuous integration pipeline. We have to use Chef or Puppet, but you have to program these scripts, and sometimes it's very difficult. With a single easy file, like the Docker file we use every time, you could create a Docker image and put in a Docker registry, and this image could use and reusable each time we want. But, okay, I create a container, another container, but I have to orchestrate all these creation. So, what is the solution? Solution is Kubernetes. Kubernetes is an open source platform created by Google about 5 years ago, and it became quickly the de facto standard for the automatic deployment, scaling, and operation of containers. Why is so? It became the de facto standard? Because it's portable, it's extensible, it's well documented. You could install everywhere, more or less, since from bare metal and from Google, from a cloud provider like Google, OpenStack, Amazon, or IBM. What is the architecture of Kubernetes? Kubernetes is a master-slave architecture. You have a single master node, not single because it's high available, but is a single point for you, because you, let me use the pointer, you integrate, you reach out with the API server. So you integrate with the API server, and a plethora of Kubernetes node, from 1 to how many you want. Each Kubernetes node contains the container. So is the virtual machine or bare metal that execute the process you want. These master and these master nodes communicate via network, via REST API. So it's a since REST protocol is the standard de facto from new application and software services, it's very, very high loaded to perform. Google decided to use REST application. Kubernetes is composed by some objects. This diagram represents this object. The unit of all this thing is the container. A single container is included into a pod. A pod is like a container group. Each container working into a pod can communicate each other through local loopback interface. So each communication is very fast, very quickly, and no time latency is there is no time latency. Who manage the pod? Because I could create myself by script a pod, but if I want 3 pods of the same application and I want that in some condition could scale up or scale down, I don't want to do myself. So Kubernetes exposed the replica set, and that extend the concept of replication controller. That it's an old concept from version 1.5, if I remember well. The replica set is a superset of pod that manage how many replica I want, and manage also the so if I want to create 3 replica automatically, 4 replica automatically, it creates, but manage also the life cycle of this pod. So if a pod crashes for some reason, the replica set, that is a controller, trigger a creation new pod. Then the superset, like the matrioskas, if the pod is the smallest matrioska, the replica set is the middle matrioska, then the deployment concept is the biggest matrioska. A deployment is the specification of a deployment of application. So I want to replicate 3 times my application. I want to give them a limit of 10 gigabytes and 0.5 virtual CPU, and so on. There is a lot of specification I could do with deployment. But with these things, I could not interact with my application because there is no exposure. All of these endpoints are internal. I could expose something to the internet. I could use service and ingresses. The service is like let me use this example. It's like a load balances for the instances. So could manage more pods and redirect all the instruction to a specific instance, while the ingress is like the DNS, is like the ISO-OZ specification. The service points to L3, while the ingress points to L7. So ingress is like the DNS translator, is a reverse proxy, while the service is the redirection direct to the specific instance. Both of these could be reachable to the internet, but what are the other things I could want to point to give you an idea why Kubernetes is so easy and so simple to use? Well, Kubernetes could manage also automatic scaling with few metrics like CPU, like number of packets given for an ingress, number of packets given for a specific pods, memory consumption, and so on is so extensible. You could add some plugins that allows to use the ELK stack, Elasticsearch, Logstash, and Kibana. In this case, there isn't no Logstash, but there is FluentD, a daemon that sends logs to Elasticsearch. You could have authorization fine-grained by role-based or an access model you want. If you want to integrate with your LDAP, you could write a plugin, integrate into Kubernetes, and you could use your authentication model. And so on. Kubernetes, for me, it's a very, very complex system, but allows to simplify more and more the work of development. Because since a few years ago, development and operation are two worlds separated. Now with Agile and Scrum and Extreme Programming, development and operation try to unify, and Kubernetes wants to be simple for developers to use and simple for operating guys to give help and understand what developer guys does. For the IBM point of view, IBM integrates Kubernetes with two different services. The main is the Kubernetes cluster that allows you to create a cluster in a specific region. And the other one is the container registry that is an instance of a private Docker registry that allows you to segregate your code. If you want to create an image and don't want to use Docker Hub as your public registry because it's the code of your application, and for obviously causes you don't want to share with other people, IBM allows you to use a private container registry. IBM offers two different plans. With a light plan, you could create a cluster with a single node with 2 CPU and 4 gigabytes of RAM maximum. Until with the pay-as-you-go plan, you could create how many workers you want, and the limit, if I remember well, is 64 gigabytes of RAM and 16 virtual CPU cores. You could decide the version of Kubernetes you want to use and where do you want to create the cluster. And when you push the Create Cluster button, then you have to wait the creation, and you could use and interact with the Kubernetes cluster like the other Kubernetes cluster. So you have to configure your kubes control CLI, and then you could perform all the kube control command you know, like kube control get pods, kube control create pod, deployment, kube control describe, and so on. So to demonstrate how you could use IBM Cloud and Kubernetes, I prepared a little video, and this QR code could help you to interact with the application I deployed. It's the same application my colleague Rosella showed this morning, but she showed from the platform as a service point of view. So she deployed it into a Cloud Foundry installation. But the same application, same code, I could create a Docker image, I could create a container, a cluster, and so on. Okay. So I create a cluster called test-gab into the Houston data center. The version is 1.7.4. When I click on the name, IBM shows some information. Here the Kubernetes version, the ID, and how many nodes and the health of each node. If I want to show the details of each node, I could see I have another dashboard that allows me to see how many CPU and gigabytes RAM, what is the hardware type. For free plan, we could use just the shared plan. So hardware is not dedicated to you, but there is some latency you could have because hardware is shared. And the identification of VLANs we created for you. We created a private VLANs for internal communication between master and nodes, and a public VLANs for communication between cluster and the rest of the net. With this dashboard, I could also upgrade the version of the Kubernetes. Here, I could show you some commands, because why I have to use Kubernetes on IBM Cloud? Why I have to choose IBM Cloud for my Kubernetes installation? Because IBM has a catalog of above 150 services, from the Watson services, from the big data services, IoT services. All these services could be binded to the Kubernetes cluster. So this binding allows to reach directly the services, and this bind create directly a kind of VLANs from the services and register into the cluster the credential of the services. So the communication is secure and is rapidly created. To interact with the Kubernetes cluster, the dashboard shows me the command. We have to use the Bluemix CLI, and then with this, after the some command, I could use the kubectl CLI. This command is to log in into the endpoint, the region I use, catch the certificate that allows me to interact to the cluster via SSL, and then configure the kubectl CLI. Something I want to point is the kubectl proxy. IBM doesn't want to block this command. The kubectl proxy is the primary access to the Kubernetes dashboard. Since Kubernetes is an open source system, we could block this command, and then if you want to see the internals of Kubernetes cluster, use the UI dashboard of IBM. We don't want this, because this dashboard is perfect for this purpose, and we don't want to replicate. So if you want to show all the details of a kube cluster, use this command, you can see all the internals. So now I try to enter into that cluster. For some reason, the video is cut, but now I listed my clusters, and you can see there is just a cluster, test-gab, created some month ago. I want to show all the details of the cluster. I want to catch the configurations. So with this export command, I configure my kubectl CLI for talk with SSL to the Kubernetes cluster. Then I deploy that application and expose it with a node port type of services. And then I want to reach out to this application. My first try give wrong port name. So I have to use the worker public IP. Let me try to repeat. It's just too faster. So when you use a node port type of services, you have to use the worker IP to talk with the application. So this is the worker node IP exposed to the public. Let me try to. But node port expose also a specific port, this one in this case. No, eh? So I have to use that IP to that port, and then I reach out my application. This application is very simple. It's a sample for Node.js and Cloud integration. And with this application, I could upload an image that we stored into a document, since Cloud is a NoSQL documental storage. And then, after I refresh my page, I could also see my beautiful face saved into the application. So, what's the next? We could integrate. We could use, a Kubernetes cluster as the infrastructure for my deployment, using a DevOps pipeline, the one integrated into IBM, for example, that allows us to use a particular service called vulnerability assessment that make a vulnerability system operating system assessment, and then show if your image is vulnerable or not. You could integrate with some services like Cloud in this case, or for an example, you could integrate with firewall of third party. You could integrate with your database. If you have a SQL database, like an Oracle one, you could integrate with that. If you are worried for credential storage, Kubernetes storage into credential into secrets that encrypted. If you are a fan of big configuration file, you could use the config set that is big but not so big. IBM allows also to make cross-region cluster. So if you have a cluster in London, a cluster in Germany, a cluster in wherever you want, you could federate all this cluster, and that's it. So thank you for your patience.
Thank you.
If you have any question, yeah.
How the different version of Kubernetes is managed by IBM? Because in our cloud, I can choose one version or another, or one version for master and a different version for the node, for example.
Yeah. When you create the same version of Kubernetes, when you create a cluster, the same version of Kubernetes is chosen for worker and master node. But you could upgrade differently worker and master node. Currently, the version supported is from 1.6 and 1.7 with the minor and patch version. But currently, I use a cluster where the master node is 1.7.5 and the worker nodes are 1.7.4. You have to upgrade manually each node and the master, because we don't want to take the risk to break anything. So you have to push the button to the side to upgrade the master node, and then you have to push the button to upgrade the worker node, making an operation that move all the pods from the worker node and to a set, and then re-upgrade. Did I answer? Okay.
Other questions?
No.
Okay, so thank you, Gabriele.